Right. So now we have to figure out, well, how do we know if our test statistic occurs less than 5% or 1% of the time under HO if we don't have SPSS? What if COVID knocks out all of our computers? It knocks out SPSS. How are we going to figure out what the probability of our test statistic is under HO? So hopefully COVID does not knock out all the textbooks in the world, because we have tables, printed tables, telling us what the probability of our test statistic is under HO. So in other words, we're going to look at a table to figure out whether we should be rejecting or failing to reject our hypothesis, HO. All right, so here's how we do it. Remember alpha? Remember I said that alpha was really important because not only does it tell us the probability of a type 1 error if we reject HO, but alpha is also going to help us find cutoff values. It's going to help us establish criteria for rejecting HO. So if we decide that we are going to use alpha 0.05, that means the risk of a type 1 error has got to be less than 5%. For alpha 0.05, you find the values of the test statistic that define the outer 5% of the curve. And these values are called critical values. Don't cry. I'm going to show you, okay? And then you can keep watching this over and over again, and you will get it, I promise. All right, so for alpha 0.05, we want to find the values of the test statistic. So values, remember, on the x-axis. That's where we put those test statistic values. And remember, this is HO. This is HO right here. This whole distribution is HO. Here on the x-axis, we have those TS values that could indicate sampling error. All right. So what we're going to do is we're going to find which of those values, which of those TS values define the outer 5% of the curve. And these are called critical values. So another way of saying this is we're going to find out which values of the TS, there's going to be one here and one here, that define the middle 95% of the curve, right? This kind of looks like Z. Remember we talked about Z distributions, and we said, well, what would be the Z scores that define the middle 95%? And you said they're minus 1.96 and plus 1.96. Remember that? These being just Z scores. Well, if we're doing like a Z test, then these would be our critical values. These are the numbers that define the middle 95% of the curve. And that translates into, these are the values that define 2.5% in each tail. That's the outer 5%, right? We have 2.5% here and 2.5% there. Those are the outer 5%. All right, so if we were doing a Z test, that means our TS is going to be a Z value. So what are we plotting on here? Well, our TSs are just Z scores. So these are all Z scores. And what we need to do is find out, well, what is going to be this particular Z score and this particular Z score to give us 95 in the middle, 2.5 on this side, 2.5 on that side. And as it turns out, it's 1.96. We didn't even need a table for that. So minus 1.96 would be the negative critical value, and the plus 1.96 would be the positive critical value. Now, these critical values are the cutoff scores once we've figured them out. So if you're not using Z, let's say using T, you're going to have to look up these numbers here in a T table. Remember Z, there's only one Z-score distribution, so we can memorize areas under the curve. But for T, you can't memorize T. You're going to have to look them up in a table. So you're going to say, well, what area, if I want 2.5% here as my area, what will be this T number? Okay, and that becomes your negative critical value. If I want 2.5 here, what is my T value? Okay, it's going to be a number here, and that becomes your positive critical value. But because it's symmetrical, as soon as you figure out one, the other one is going to be the same. It's going to be the same number, only negative, because all this is symmetrical. All right. So critical values then are special values of the TS. It's not the one that you calculate. It's a special value of the TS that becomes your critical value. All right. And it's like a cutoff score. So if you determine that your critical value, let's just say for argument's sake, it's 3. All right, let's just pretend it's 3. Then you look at your TS that you calculated, or SPSS. What did you calculate for your hypothesis test? If, let's say, this number is 4, then you know you're in this area. And if you're in this area, you can say that the probability of my TS is less than 5%. You won't know exactly what it is, but you know it's less than 5% because this whole area here plus this whole area here is 5% of the curve. So this has got to be less than 5%. Now you might say, well, Lynn, why can't we just say less than 2.5%? Because this is only 2.5% here. And the reason why you can't say that is because you did not know that you were going to be here in this particular tail. Maybe you were going to fall here. So what you need to do is report the total area. All right, so it's 2.5% here, 2.5% here. So the probability is less than 5%. And it's less than 5% because you're already a certain distance into the curve. All right. So the rule says if your test statistic falls in, we're going to call this a rejection zone. Why? Because it's bigger than the critical value. And remember the rule, if your TS is bigger than the critical value, reject HO. So any test statistic that is in a rejection zone is one that we say is significant. And is there a risk of a type 1 error? Yes, you rejected HO, and so you might be making a type 1 error, but you can relax because the risk of a type 1 error is less than 5%. Why is it less than 5%? Because that's what you set alpha to be. You said alpha at 0.05. You said, I don't want my risk of a type 1 error to be greater than 5%. It's got to be less than 5%. Okay, so that means you want to block off 95% of the curve. This is where you don't want to be, okay? And if you are here, it means that your risk of a type 1 error is greater than 5%, right? It can be as high as 95. So if you get a test statistic value that is in this area, well, you're going to keep HO. You're going to fail to reject HO. Okay, remember, fail to reject. But if you're in a rejection zone, then that's combined, these two areas combined is 5%. That's where your alpha 0.05 comes in, 5% of the curve, but it's the outside. So that means 2.5 in each tail. And as long as you're in one of those two tails, you met the criteria. All right. And how will you know if you're in this area? Look at the value of your TS and compare it to the critical value. If your TS is larger than whatever this number is, it means you're either here or you could be in this tail. Go ahead, reject HO. The probability of making a type 1 error is less than 5%. Your results are significant. Now, you may need to go over this a couple of times, okay? The first time you hear anything, it can be a little perplexing. But don't forget that reading your book is also going to help a great deal. Read it, hear it, speak it, write it, engage all parts of your brain. All right. So once again, how are we going to know what these numbers are? You get them from a table. I've already shown you how to use a Z table. If you can use that Z table that I gave you, you can use a T table. But basically, you're just looking up for 0.05. You're saying you want 0.05 or 2.5% rather, in two tails, right? 2.5% in this tail, 2.5% in that tail. You can look that up. You can say, well, what would this area be? All right. So if you're using a Z-score table, remember the one in the book gives you the area between 0, right? Right here in the middle would be 0, 0 and the Z-score. So in the table, if this is 2.5%, what will be this leftover chunk from 0 to Z would be 47.5%. So you look up 47.5% in your Z-score table, and that number is going to be 1.96. All right, and that will give you 2.5% in the tail. So again, with modern technology and SPSS, we don't generally do any of this by hand, but we still teach it. Why do we still teach it? I mean, isn't it so much easier just to look at SPSS and look at the sig value, and if it's less than 0.05, we know it's significant, and our risk of a type 1 error is less than 5%. Yeah, it's easier, but without understanding what the software is doing, you might actually come to a false conclusion. All right, and so this is just helping you get a really good understanding of hypothesis testing. In high school, unless you took an AP class, we wouldn't talk about this, but you're beyond that now, and this is something that is going to be helpful moving forward. Again, it's so important to know what hypothesis testing does and does not do. We need to teach it at this level.